Welcome to Mrs. Baez's 6th grade math video lesson. This is the 3rd video in the prime factorization series, and we're going to focus this lesson on prime factorization. Please do not use a calculator, but you may use your multiplication chart. Let's begin by looking at our vocabulary. First, we have factors. Remember that factors are numbers that we multiply together. A prime number is a number that has only 2 factors. In prime factorization, it is the prime factors multiplied together to get a product. Now notice the factors need to be prime numbers for prime factorization. Well, let's look at how we can find the prime factorization of a number or of a product. There are 2 methods I want to show you today. First, we're going to start with the tree method to find the prime factorization. Well, the tree method kind of resembles a tree. So let's look at our first example, and this is the number 12. So for 12, we want to start by thinking about what 2 factor pairs equal 12. So I'm first going to start with my 2 branches. And when I think of this, I want to think about the smallest prime number first. So let's think 12. The smallest prime number in 12 that has a factor pair would be 2. 2 times what is 12? 6. So now we need to think, well, 2 is prime, so I want to circle it. And that means I'm done with that branch. I have found the prime factor of 12. Well, now let's look at 6. Well, 6 is composite. That means we can multiply 2 factors to get 6. So what's the smallest prime number that we can multiply by to get 6? Well, that's a 2. 2 times what is 6? 3. So now we need to think, 2. Is 2 a prime number? Yes. We circle it. Is 3 a prime number? Yes. And we circle it. And we are out of branches. That means we are finished. Now let's write the answer. 12 equals, and now we're going to list the factors, these prime factors, in order from least to greatest. So I have a 2 times a second 2 times 3. And that is my prime factorization. Now let's look at the second example, and this is 20. So let's start by making our first 2 branches. What would be the smallest factor that we could use to get 20? Well, that would be a 2. But I want to do something different on this one. Could we use something other than 2 but still get the prime factorization? Well, the answer to that is yes. So what times what gives us 20? Well, what about 4 times 5? So we have to ask ourselves, well, 4. Is 4 a prime number? Or can we break it down into 2 more factors that could be prime factors? Well, yes, we can. What times what is 4? Well, 2 times 2 is 4. Is 2 a prime number? Yes, and when we say yes, we circle it, saying that that part is finished. And that means that this 2 is prime, so we'll circle it. Now let's go to this branch, 5. Is 5 a prime number? And the answer is yes, so we circle it. And we are out of branches. We can write our answer. So here it is, the prime factorization of 20. 20 equals, and again, we're writing them in order from smallest to largest, 2 times 2 times 5. And that is our prime factorization of 20. Let's go to our third example, and this is 36. So let's do our 2 branches. What times what is 36? Well, 6 is an even number, so that means 36 is an even number, which means we could divide by 2. So let's try dividing by 2. 2 times what is 36? 18? Is 2 a prime number? Yes. Is 18 a prime number? Well, let's think back to my hundreds chart. Did we highlight the number 18? No, we didn't. 18 is composite. That means that there are prime numbers in 18. So let's split 18. What times what is 18? Well, how about 2 times 9? 2 is a prime number. Let's circle it. What about 9? Is 9 a prime number? No, it's not. So let's break that off into its 2 branches. What times what is 9? But we need the numbers to, at least one of them, to be a prime number. Well, what about 3 times 3? 3 times 3 is 9. Is 3 a prime number? Yes. So we circle it. And is this 3 a prime number? Yes. So we circle it. So now let's write our prime factorization. 36 equals, and again, we're writing these in order from the smallest prime number to the largest. So that would be 2 times a second 2 times 3 times the second 3. That's the prime factorization of 36. Now let's go to our last example, and that's 17. So what times what is 17? Well, 17 is an odd number, so we try to divide it by 3, which is an odd number, and we can't divide 17 by 3 evenly. So what would be the prime factors? Well, we have 1 times 17. Can we break that either down any more than that? And the answer is no. So now let's go back to 1. Is 1 a prime number? Well, think back to my hundreds chart. 1 is not a prime number. It is a factor that we can use to multiply by another number to get a product. And that's what we did here. 1 times 17 is 17. So we're not going to circle it because it's not a prime number. So now think back to 17. Is 17 a prime number? Did we highlight that on my hundreds chart? The answer is yes. So the prime factorization of 17 is 17. So on this page, I showed you 4 examples using the tree method. Now I'd like to show you another method, and that way you can decide which method is best for you. And this is called the cake method. The cake method, you got to think about, let's say, a wedding cake. A wedding cake has layers, and each layer gets a little smaller than the layer below, till the top layer is the smallest of all the layers below. Let's look at number 1, and I've already got my first layer of cake, and it's a 12. So now I'm going to think, what is the smallest prime number that goes in a 12? Well, that's a 2, so we put that out front. Now, 2 times what is 12? Well, that's 6. So that means I'm going to make another layer of cake and put a 6 there. Now, what's the smallest prime number that goes into 6? Well, that's a 2, and that goes out front. And 2 times what is 6? Well, that's 3, and that goes on top. So now I look at it and I say, well, 2's a prime number, 2's a prime number, and 3's a prime number. So now I'm going to write my prime factorization. 12 equals 2 times 2 times 3. If you think about using the smallest prime number for each layer of cake, they will already be in order from smallest to largest. All you have to do is write them as they go up the left side of the cake. Let's look at the second example with the number 20. What is the smallest prime number that you multiply to get 20? Well, that's a 2. 2 times what is 20? Well, that's a 10, so I need a layer of cake and put 10 here. All right, let's think about 10. What is the smallest prime number that would go into 10? Well, that's another 2 because it's an even number. And 2 times what is 10? Well, that's 5. So that means 5 goes on top. Now let's look at the numbers on the left side. Is 2 a prime number? Yes. Is 2 a prime number? Yes. And is 5 a prime number? Yes. So 20 equals the first 2 times the second 2 times 5. And that is our prime factorization for the number 20. All right, let's look at 36. 36 is an even number, which means we know our smallest prime number is going to be a 2. 2 times what is 36? Well, that's 18. Well, 18's even, so that means we need to make that a layer of cake. And since 18's even, that means the smallest prime number would be a 2. So 2 times what is 18? Well, that's a 9. Well, 9 is an odd number, so we should try dividing it by 3. So let's make that another layer of cake. And let's see, 9 divided by 3 is 3. So now let's look at the prime numbers. Is 2 a prime number? Yes. Is 2 a prime number? Yes. Is 3 a prime number? Yes. And is 3 a prime number? Yes. So now we can write the prime factorization of 36, starting with the bottom layer of cake. That would be 2 times 2 times 3 times 3. Now let's look at the fourth example, that's 17. We need to think about the smallest prime number that would be in 17. Can we use 1? No, we can't use 1 because 1 is not considered to be a prime number. 1 is used as a factor in all numbers. So what would be the smallest prime number? Well, in this case, it is 17. 17 times what? 1. Well, 1 is the smallest number we can use here. So do we have any other layers of cake like what we've done here with example number 1 with 2 layers, and example number 2 with 2 layers, example 3 with 3 layers of cake? That looks more like the wedding cake version, right? Now, number 4 is 17. So what is the prime factorization of 17? Well, 17 is the only prime number. So that is your prime factorization. That's all you write. Okay, I've shown you 2 methods, the tree method and the cake method. You need to think about which method is best for you, and that's the one you should practice. So now let's talk about the practice. For practice, I want you to do IXL, 6th grade, E.6, and you should see the words prime factorization. You can use either method that I showed you today. Please remember, 80% will give you full credit and 100% will give you a bonus point. Good luck!